So what's the appropriate setup for this type of application? To give an indication of the easy way to highlight and outline what the requirement is, here we have a daily worksheet. So the daily component and work area checklist. So the checklist itself fundamentally goes through what the requirement is. What do I need? An air compressor, air supply, bull hose, air moisture control, and that's why I talked about air preps. We need the blast machine, which we have here. We also need the blast hose, which is attached to the bottom of the blast pot, couplings, and this inherently makes you check what you're actually putting together and what you're appropriating to do the job. On the end of the sheet here it says other protective clothing and work hazards. So I want you to understand that there's not only you're doing the job, what you need to understand as well is that you're having an effect on the environment. So there's the noise levels, and also what am I blasting? Have I made sure that anything that doesn't need to be blasted has been removed? So all of these are fundamental requirements in relation to the process in moving forward. So here it shows you a compressor, an aftercooler, your blast pot, the guy blasting, he's got his blast helmet on, he's got a CO2 monitor, he's got a breathing air filter and an alternate compressor if required. Why do they have another compressor there? If this compressor wasn't big enough, of course he would have to install another compressor to facilitate the air to help him breathe. Predominantly what we do is we'll have one compressor large enough to operate our aftercooler or air prep. We'll have the compressor large enough to operate our blast pot as well, and also too we'll plug our breathing air into that one compressor. So it's important to know that your compressor is large enough to do the job, and as we go through this whole process we'll help you understand what I require to make sure that I do have enough air to facilitate all this requirement to have a good outcome in relation to blasting. So I suggest that this is utilised every day, and it's put with your JSA or JSHAs to ensure that all this paperwork has been checked and filled out. And there's nothing wrong with having another person check what you put together as well, because you've got to remember that this is a high velocity equipment, and the high velocity outcome can be detrimental to people's safety. So the whole aspect of this is to keep you safe. Just moving on from that, we have a small booklet that goes with this particular application. This small booklet is called Surface Preparation Guide. What this does is it shows you the rust gradients, so it gives you an outline of what the gradient of rust is, and then it goes through the class of blast. So everything we do as far as blasting is concerned is relative to a standard. The standard is outlined by these particular nominations throughout the book. So we start off with rust grade A, and we'll go through to rust grade B, C and D. So when we get to D, there's quite a significant difference between rust grade A and D in relation to its pitting and so forth. So this is why it's important that you understand what your equipment is capable of doing, how much air do I need, what size nozzle do I need, and how do I appropriate all that equipment to facilitate the appropriate outcome in relation to the class of blast. Because when you're blasting, you are blasting to a class, and we all refer to that class in relation to what the requirement is. The requirement is also outlined on a specification, so the specification complements the class of blast and is written and nominated for you to adhere to and comply to in relation to an outcome. So this book also too has a lot more information on it. As far as setting up your equipment, what you may require, which again it nominates an air prep as mandatory. Also gives you a brief description on the valving, which is metering the amount of abrasive coming through the blast line. More importantly too, it gives you an indication, there's a chart here that gives you an indication of air consumption. So as far as our nozzles are concerned, we go from a number 2, which is an 1/8, right through to a number 12, which is a 3/4 inch nozzle. The whole idea of this graph is to give you an indication of how much air I required for what size nozzle. So today, for example, we'll be using a number 7 nozzle, and we'll be blasting at 100 psi. So of course we'll need a 312 CFM compressor. So how does that work in relative terms? I have to make sure that I have appropriate air pressure and volumetric air to facilitate the appropriate outcome of this particular blast nozzle. So what we've done here is appropriated our gear for blasting. So we have an air prep to ensure that we have no moisture in the air. We have a breathing air filter, which is a Radex filter, the breathing air line, twin man's connected, twin line dead man, the valve's off, the bull hose is connected. But if you look at the bull hose further up, you can see there's a crimp in the hose. So when you appropriate your bull hose, you must make sure that this doesn't occur, primarily because it can twist the twist lock fitting off the parent fitting and cause the hose to fatigue where the crimp is. So if you find that when you set your hoses up and attach it to the equipment, there's a crimp in it, or it's an indentation such as that, disconnect it, reconfigure your hose so that you eliminate that type of restriction. From the air prep as well, we've got the 1-inch 25mm supply line of air to a regulated air line on the other side of this, which is on the side, and then you've got a gauge on the top, and then we've got 2, 4, 6 outlets on the top, so 6 helmets can run off this one filter. Does it have the capacity to do that? If it's got the volume of air to feed it, absolutely, it can accommodate 6 helmets. So the one thing you've got to remember when you've set all this up is that the compressor, but has it pre-checks? Is it in the appropriate place? Is the bull hose arranged in long radiuses for the hoses? Has the air prep had its pre-checks done, such as oil and so forth? Are the valves that we don't wish to utilise closed? Is the abrasive blast hose set in such an arrangement that it has long radius instead of sharp radiuses on the hose? Ensure that your breathing air line is not in a place where it impedes traffic. Same with your blast hose. Also too, arrange your breathing air hose so that it is divorced from all other traffic so that no one can trip on it, can't be run over and so forth. So ensure that all your safety clips are in your claw couplings or mince-up couplings. Make sure your whip checks are secured appropriately and tight, taut, with no slack whatsoever. Then you can go through and make sure your vents are open on things like your moisture accumulator, on your air prep primary in, the bottom of the air prep, slightly crack that valve open, and also too on the moisture accumulator on this particular vessel here, which is on the blast pot, just crack that valve open slightly. So now when I turn the air on, what will happen is I have these valves cracked. So as I open each valve, I can check that there's the right amount of consistency of air and exhaust in these particular units. The most important one is this particular unit here. On the bottom of this unit there is also a bleed valve.